Uh, okay. Good afternoon, all my dear students. So, dear all students, am I audible and my screen is visible to everyone, please?
Yes, sir.
Yes, sir.
Okay, thank you. Uh, okay, dear all students, due to some I am busy with the institute work yesterday, so I didn't took the class lecturing. Uh,
Can I?
yeah, please, anyone. So yesterday's one lecture. Already I took one extra class in previous of your week. So anyhow, we are in on an average for the classes. Just it is my one apology basis to everyone for the yesterday's class lecture. So today we will start with new concept. That is before we will start new concept. So again, as our uh, daily routine lecturing, participants can now see your screen. Okay. So every daily routine of lectures, we will go through first 5 to 10 minutes for your open forum questions discussion. So, dear students, just in previous days after my last lecture, so I got only three questions. Only three questions I got from two students of your classmates. So just I will go through it. I think is only these three questions. Just I will uh, just read out the three questions. If any other questions are there, please you reply me through the message because I bulk of messages I got, so I may miss one or two questions as what I feel. But if like so, please reply me. The first question one student is asking this slide. He is they saved this slide. In that slide, he is asking what is DMA. DMA stands for what? And one more he is asking NMOS. What is NMOS? And the second question, one more student is asking, in the 8086 memory, there is only a 1 MB storage. How this is possible to work with this microprocessor? So this one also I will explain. This one also I will explain. So next, uh, just paste it here. Okay. So next question, same students is asking, and finding the physical address, there is a required of segment address and offset address, but in the architecture there is only one offset address. So what is the working of SI and DI? Means source index, destination index, stack pointer, and base pointer. This is third question. So please, apart from these three questions, any more questions are there? uh, Maybe can I miss any questions? Other students, please reply me through the message if any other questions apart on these questions. Okay, I think I didn't got any message, so I think only these three questions. Yes, okay, fine. There. So 83 students are there. Remaining students who want to join, please. And I admitted I enable for joining. There is no any security issues. Yes, fine. So okay. If there's no any other questions, right, apart from these three questions, yes, fine. So now we will go through those three questions. So dear students, so the first students who are asking the question, it is N type metal oxide. Okay, fine. such semiconductor, that is nothing but we are going to design using NMOS, that features of 8086. And same question he is asking in that only, that is what is DMA. DMA is nothing but uh, dynamic memory access. So there are two types of memory access, right? One is static memory access and one more is dynamic memory access. So it will support it. Please all of you make mute. Who is there? Okay, fine. So here that dynamic memory access means randomly you have to access the memory. Static means constantly you have to access. Dynamic means randomly you have to access the memory. That memory accessing in the dynamic is it will supports it supports the 8086. It supports that dynamic memory access. So this is the first question. I think I cleared you. Or is there any more doubt also? Please you ask. So next I'll move to the question, second question. So in the 8086 memory, there is only 1 MB storage. So how this possible to work with this processor? So here, see, the 8086, it is only, all of you please be remember, I'm very thankful to who are asking this question, dear student. 1 MB means how much? That is 1000 KB. 1 MB means the memory is 1000 KB. So why we have to use 1 MB means it is this 1 MB means you don't understand. It is like we have to work all the microprocessor work in this 1 MB only. It is not like that. I think you may misunderstand. So one example I will give you, in a computer, in a laptop, we have to use, one is RAM and one is hard disk and RAM, right? So hard disk maybe we have to use 256 MB, 512 MB, 1 TB, as per our requirement. In the multiples of TB also we have to use, that is the hard disk. So hard disk is different, RAM is different, and in the RAM we have to use either RAM ABA 512 MB or 1 GB, 2 GB, 4 GB, 8 GB, 32 GB. So RAM memory is different, hard disk memory is different. Whatever you are going to do the work on the screen is visible, that is going to be work in the RAM, and whatever you done that work, that is going to be stored in the that hard disk. Hard disk is having a huge memory, it is a storage memory, but RAM is only small memory, very less memory. For the working purpose we have to use it, right? So like that in the microprocessor also, 1 MB you have to use for only for the mnemonics instructions, whatever instructions you have to use it. So today's class I have to start instructions, that time you will come to know. For example, move, move, move is a one instruction. That instruction is even fraction of kb is more than enough. You will not need 1 MB. Fraction of kb is more than enough. For thousands together instructions is, you have to use it within 1 MB, because that's only working condition. Like RAM is how it is having a very less memory, compared to hard disk. Like that, this microprocessor that is using only 1 MB, very less memory is more than enough. 1 MB is more than enough, and remaining whatever your work output conversation is you have to get, that is with the hard disk memory. So that hard disk memory you don't merge with your this microprocessor memory. So for that microprocessor, 1 MB is more than enough for to do the work, and remaining all the work are carried with hard disk, that is secondary. Okay, so am I clear this one? Who are asking this question? Please, who are asking this question? I think I cleared. If not cleared also, please message me again, I'll try to clear it. Okay, so this question means you are, I think you are thinking about an entire work how we have to done in a single 1 MB of memory. It's not like that. In 1 MB you only the mnemonics, that instruction is going to be uh, stored. That purpose you have to use, that is more than enough in the microprocessor. Remaining all work are carried out in the hard disk, because remaining external storage or the external space. So in that hard disk there may be a 512 that is 500 MB or 1 TB, more than the space is available. So I think I cleared this. If you don't have cleared, please raise the fives. Okay. I think आपको सबको समझ में आएगा ये second question. So in the third questions, I'll go through it. Uh, a continuation with the second question. Same student he is asking, and so for finding the physical address, there is a required of segment addresses and offset address. So segment addresses are nothing but these are the segment addresses: uh, source index, destination index, stack pointer, and base pointer. And source segment address and offset address. But same, he is asking the question. But in the architecture, there is only a one offset address, that is instruction pointers, IP. There is a one IP address. So, sir, what is the working of source index, destination index, stack pointer, and base pointer? What is the working? He's asking. So his question, what I understand about his question is, what is the use of source index, destination index, stack pointer, and base pointer if we have to use only one offset address, that is instruction pointer? Exactly his question, I think. So, dear student, it's not like that. So, what is the offset address? The offset address, that is the instruction pointer, you have to use it only for to fill 20 bits out of 16 bits, because all these source index, destination index, stack pointer, and base pointer, these are 16-bit capacities. 16-bit capacities. Please try to understand. It's very important. Really thankful to this question who are asking. So source index, destination index, stack pointer, and base pointer, these four are 16-bit length. But our address line is 20 bit, right? Address bus. That is a 20 bit. So remaining send out because you are currently sending in the devices. Okay. So because these are the 16 bits and remaining 4 bits, address bus is totally 20 bits. So we have to fill remaining 4 bits. We are using offset address. That time also I will explain this thing. So only for filling that remaining 4 bits, for that purpose we are using instruction pointer. So this instruction pointer we have to use it along with all these four to fulfill of all 20 bits in the address bus. To fulfill of all 20 data lines in the address bus, we have to use instruction pointer along with all these three. We didn't use separately IP, and these all are segment addresses. These four segment addresses we have to use along with one offset address, that is instruction pointer. So like this, so this is the explanations. You look into this. So these are the general purpose registers: A, B, C, D with HR, that is AX, BX, CX, means general purpose registers. And these are the segment register, special register, stack pointer, base pointer, destination index, source index. So along with these, we have to use this IP, instruction pointer, instruction. So separately, that's what we have to use. This instruction pointer, 4 bits, we have to use it along with. And finally we have to make it as a 20-bit line. Finally we have to make it as 20-bit line. And whenever you are going to use that instruction pointer offset address, that time flags should be there. Flags, all different types of flags we have to study: zero flag, sign flag, parity flag, direction flag, like that. All 9 flags we studied in 8086. So for that, this IP address, that instruction pointer is along with this 16-bit 4-bit instruction pointer. We have to use it with 16-bit different segment addresses, and we have to fulfill all 20-bit address line capacity. So this is the answer. So here also I have to mention stack pointer, base pointer, source index, and destination index. So these all are 16 bit only. 16 bit, this is 16 bit, this is 16 bit, this is 16 bit, because the address bus is a 20 bit. So to fulfill this 20 bits, we have to use instruction pointer of 4 bits. Okay, so this is the answer for these 3 questions. So apart from this, I think all of you satisfied with my answer. Yeah, am I cleared? Okay, is there any more questions? No questions. Okay, that time I said that to him, I will explain you. So I think I explained, I answered your questions. All these only 3 questions I got. So if there's no any more questions, then I will share with you this word pad. I'll share with you this word pad now. Okay, just a second. Okay, he yes, thank you. He replied yes, sir. Thank you. Fine. So just I will share with you in the microprocessor group, our open discussion group, that is microprocessor. So in that, just I will add. Okay. So on today's date, that is 28. Okay, 28 open discussion. Fine. Fine. Yes, I shared with you. Please, all of you go through it. Still, I will wait 1 or 2 minutes. Still, any more questions in the previous 1 or 2 unit number one and unit number two? Because today I will go to unit number third, as well as we will parallelly start with lab sessions. So please, uh, all of you installed that TOSM software, whatever I taught on that last lecturing.
Yes, sir.
Yes. Is there any doubts to installation in that? And is there any doubts how to opening, how to use that four different commands: edit command, TOSM command, objective command, T-link command, executive command. These four commands are very important for we doing the work with TOSM software. So still also, if you have any doubts, you have to pay to ask. So today onwards, what we will do? We will do. We will start third unit, because your third unit is totally instructions. So dear all students, at the beginning, I am saying you from the beginning. Always 1 or 2 first unit is totally introductions. There is no program related. Just it is 8086 introductions. Sorry, 8085 instructions in the first unit, and in the second unit, that is 8086, entire the architecture of 8086 and address modes you studied, and execution timing. Just you studied theory part of execution timing, architecture of 8086 and addressing modes you studied. So actual your instructions topic started from third unit onwards. So I will open that syllabus. See, this is your syllabus. That is just a second. Mm, so, okay, this microprocessor. So in this, uh, so all of you please observe the syllabus. In the unit number one, you studied only theory part of 8085. That is architecture of 8085 you studied, and introduction of 8085 you studied, and features and pin diagram of 8085 you studied. Just it is a theory part. There is no instructions part in this. That's what we didn't started any lab programs that time. And in the second unit also, architecture of 8086, that is uh, just a theory part. That one block diagrams and architecture we have to explain. And next we studied operations. There are three instructions: fetch one, instruction fetch two, instruction fetch three. With the odd and even we studied. That is also a theory part. And in machine languages, in that machine language instructions, just we studied addressing modes, all data transfer, data related addressing modes and branch related addressing modes we studied. After that, we studied instruction execution timing. That one list I given to you, that is a fixed value of instructions with a particular addressing modes. So again, this second unit also a entire theory part, no any programmatic or any instructions. So actual instructions starts from assembly language program. Actual instruction starts from assembly language programs. So in the machine language instructions also you studied in the second unit, but in the third unit, that is assembly language instructions. So in that you are going to study all the instructions of 8086. That is 8086 instruction set. Minimum around 50 instructions are there every day. Very few instructions, about uh, 10 to 12 instructions we will study. So actually, it was as per university's prescribed, it is 6 hours, but I will take minimum 8 hours, to cover this unit, because each and everything thoroughly in depth we will study. This is main basic foundation for your practical part, for your lab sessions. So that's what we have to take more, and we will learn only few instructions per day. Out of 50 every day we will learn 10 to 12 automatically. Within 4 days we have to complete this entire third unit. Okay, instead of our 6 units, 6 hours, we will take minimum 8 hours to complete this uh, unit. So we will learn in depth. Okay, so in this we will learn all the instructions whatever comes under the 8086 microprocessor, all the instructions. So this is the syllabus of your particular semester. So now I will go through first instructions. Once we learn the instructions, once we learn this topic from the unit number 3, then we will automatically easy to practical sessions. Along with that, whatever instructions we have to cover, based on that instructions we will start lab session also. Okay, so dear all students, is there any doubts from these two? If you don't have any doubts, I will move to today unit number 3. As per your prescribed university syllabus, unit number 3, I will move it. So for this, again, I have to prepare well notes. I will transfer to you. Even I will prepare PPT also. I have to given to you. Okay. So this is the your, that is unit number 3rd PPT with the assembly language programming. Assembly language programming, 3rd unit. Okay. So here, dear all students, uh, in that unit, so the syllabus is assembly language programming. In that, as per you have to saw now, that is 80 assembler instruction format. What is the assembler instruction format? Means that mnemonic format and instruction set directives. So these are, I have to mention, assembler instruction format. First point of the syllabus. Second point, instruction sets. So all the instruction you will learn. If you perfect in this topic, your practical becomes very easy. Your practical programs becomes very easy. So that's what, with slowly we have to learn in depth this point, that is 8086 instruction set. And at the last, directives are comes. Again, it needs one class, is more than enough. Very small topic, directives. So for the unit number 3, all of you take this textbook, that is a microcomputer systems, the 8086 or 8088 family. The author name is Chuang Liu and Glennon A. Gibson, with a second edition. Same textbook you have to use it for second unit also. So same textbook you used here in the third unit of your syllabus. So and along with that, whatever I have to given you printed notes with my handwritten notes, that one also all of you have to provide it. You have to read it. Okay. So this is the at the beginning summary of the unit number 3 with all the syllabus, textbook, and my printed notes. So next, I will move to the topic. The first, that is assembler instruction format. That is first point I have to take as per syllabus, assembler instruction format. So this is the first point, assembler instruction format. So in that assembler instruction format, so dear all students, am I audible, right? My screen is also visible to everyone, right?
Yes, sir.
Yes, sir.
Okay. Okay, thank you. So this is the first point as per your syllabus. So that is assembler instruction format. So what is assembler? The assemble means what? We are going to join. We are going to add. For example, sometimes we have to say our computer as a assembly computer. What is that meaning, assembly computer? The meaning is that one desktop we have to take from one company, and keyboard we have to take from another company, and mouse we have to purchase from some other company, and entire that PC, that is we have to take for some other company. So all different company materials we have to make it a single computer with a different company names like mouse, keyboard, monitor, desktop, like that. So all we together assembled and make it as a one working functionality system. That one we call it as a assembler. That one we call it as assembly. So such kind of working what we are going to join, that is the assembler. So what is the assembler? Like this physical devices, here in the microprocessor you have to use different instruction format that you are going to be assemble. So in that, what are the main types of assemble? That is, first is label. The first one is in the assemble. Dear all students, one more time I will repeat you. Today I have to started third unit. Please, all of you, please be regular, be attend the classes, and please be more concentrate on, because this is a basic fundamental for practical session. Because once you learn all the instructions, your practical is becomes very easy to you. So please, I request you more concentrate on this. Okay. So in the assembler instruction format, the first part is label, second part is mnemonic, third part is operand one. So I make it as operand one because it is list of operand, and operand two, and n number of operands you have to use. And at the last is comments. How it looks like, I will show you in the notes. So here, dear all students, this is the things, that is label. So this is the one example. All of you please carefully listen. This is one example. In previous units, all of you used move ax comma bx, or move ax comma some value like 0037h, like that. But here, whatever I used, this all the words label, mnemonics, operand one, operand two, or n number of operands you have to use. Operand one and operand two, you may call it as operand lists, and last is comments. How we have to declare this one? This one is declared in like this. That is, first one is a label. What is label? Here I have to use it BR. The BR, in the sense it is a branching. While writing the microprocessor programs, for the branching purpose, we have to use this label. So it provides, means branching to this instruction. Call by value, call by references you studied, right, in the C programming, and go to statement, jump statement you studied in the C programming. So what all those are doing, that is the branch, created the branch, and you have going to call particular line instructions and you'll get executed. So same way in the microprocessor, here that label we have to using for the branching purpose, and branching with almost it is with the colon. So branching label, yeah, whatever the label name you have to give. For example, loop one, you have to use the loop with the colon, and this is the what? It is the instruction. What is instruction? We call it as mnemonic. Instruction is nothing but mnemonic. What is this instruction? The name of the instruction is add. So add in the sense addition of two numbers, or it may be a sub in the sense subtraction of two numbers. Just one example I given, addition instruction. So this addition is an example, that is a mnemonics. So what is the format? Label, colon, instruction, name of the instruction. Next, you have to use operands. So first is label is over, mnemonic. Next you have to use operands, list of operands, n number of operands you have to use. That is, ax one operand I have to use it, and one more bx operand I have to use it. So bx operand I have to use it for to find the count. That's what I will use the variable count with the bx register, and here ax1 register. So operand 1 is nothing but ax register, operand 2 is nothing but bx register, ax and bx. So whatever that functionality, we look into that later, but only you have to understand that format of instruction. So what is this? It's the label. whatever we are going to do the branching, that's what it indicates, the provides the branching of this instruction. Second one, that is the name of the instructions, whatever the instructions you have to use. So in my example, I have to use the add instruction. That's what I mentioned. That is nothing but a mnemonics. Commonly we say it, generally we say it is a mnemonic. And these two are list of operands. So here I have to use the two operand. The name of first operand is AX and is nothing but registers, and the name of second operand is BX, which is the count. So after our instruction is over, declaration of instruction is over, next we will do command. So after semicolon, so first with the label we have to use the colon, and with the comment we have to use a semicolon. So in your C programming, you have to use a double slash, right? Double slash. But here in the microprocessor for the comments, you have to use colon. Colon in the sense it is a commenting line. So what this instruction is showing, that comment line, add the element of count. Whatever the count is there in the BX register, that count of BX register you are going to add into the AX register. That is the entire meaning of this instruction. What is this entire meaning? That is addition, to add the count whatever containing the BX register with the AX register, and final result you have to store it into AX register. That is the meaning. So this is the command line. What is the addition of elements for count to AX register? So this one we have to say comment. That comment we have to indicate it with semicolon. This is the first point of that assembler instruction format. This is just a format. What is the format? Label with a semicolon, and give the mnemonic. Mnemonic is nothing but your instruction, and the operands are nothing but your registers, any kind of registers you have to use it. And finally it is a comments for user understanding purpose. We have to give the comments. We have to give the comments, that is label, mnemonics, operand 1, operand 2, n number of operands you have to use it. And this is the comments, that comments you have to give. This is the assembler instruction. That explanation also I have to given whatever now I explained. So same explanation, so you have to go through it. Okay, today I will share with you these notes, no problem. So along with that, some one or two points just I recall to you from the previous chapter, previous unit. So in that previous unit you have to study the various operands and syntax as of the operands. What are those? So those are nothing but you studied some addressing modes, right? So addressing modes and format of that addressing modes you studied, and some examples also here I mentioned just for your reference purpose. So what are the addressing modes you studied? Data related addressing modes you studied, and branch related addressing modes you studied. So in the data related addressing modes you studied immediate addressing mode, direct addressing mode you studied, register address mode you studied, and register indirect addressing you studied, register relative you studied, based index register you studied, relative based index you studied, right? So with the different, just I recall to you from the previous chapter, just one or two pages I use it here. So and branch related also you studied. In that branch related, that two types of inter and intra segment. Again in the inter and intra segment, that is direct and indirect we studied. So totally these are four types: intra segment direct, intra-segment indirect, and inter-segment direct, inter-segment indirect. All we studied in depth in the previous series. So just you go through it. So next, one more thing in the microprocessor, the base is very important. What is base? Base in the sense either you have to use the numbering system. You have to use the numbering system. Either it may be in the binary, or it may be in the decimal, or it may be in the octal, or it may be in the hexadecimal. So all these four different numbering systems you know, right? Because you may study it in basic electronics of your first or second semester, right? So binary numbers you studied, decimal numbers you studied, octal numbers you studied. hexadecimal numbers you studied. So binary numbers you have to uh, indicate by the suffix of b, decimal numbers you have to indicate by the suffix of d, octal number by the suffix of o, and hexadecimal by the suffix of h. So these are four different numbering systems. Because by knowing these four different numbering system, we have to convert one form to another form, one number system to another number system. So here, first one, that is a binary number. Why they call it as binary number means in the olden days, and before when they started the mathematics, that time the peoples are knowing only two numbers, 0 and 1. Apart from 0 and 1, the people are not knowing any other numbers. So they are using in olden days, that time they called it as only two numbers. For that we said binary numbers. Binary means two, 0 and 1 number. So nowadays, after that, they have to use the fashion of 8 numbers, 0 to 7, 0, 1, 2, 3, up to 7 numbers they have to find out. 0 to 7 means totally 8 numbers they have to implement it, and they started work on that seven numbers. So that system, that seven system, they called it as octal. That is octal. And in a normal as usual basis, we have to use it whatever the number system, that is decimal number system. Decimal number means what? That is 0 to 9 numbers, we call it as decimal number. So in an every day ruling purpose, we have to use this decimal numbers. So after this decimal number, some of the electronics purpose, some of the computer purpose, again some more they have to add it, they have to implement it. Up to 16 means 0 to 15 means up to 16 with the a b c d f value. Up to that 0 to 9 they have to use it a b c d f value. So that number system we say that is hexadecimal. We say that is hexadecimal. So for the storage purpose, we have to use these four numbering system, either binary, decimal, octal, or hexadecimal. So H in the sense hexadecimal, O in the sense octal, D in the sense decimal, and B in the sense binary. So wherever we are going to use these four systems, that time we have to use suffix with these b, d, o, h. For the decimal, we didn't use suffix. Normally, we have to use just a number. It means that the decimal number, by default, it is having a d suffix. Because of it is a normal usage, we didn't use a d. Apart from decimals, whatever other numbers we are used at that time, particularly we have to mention with the suffixes b, o, and h. For decimal, we are ignoring. By default, it is there for the decimal. If there is no any suffix is there means we understand by default it is a decimal number. So that's purpose we may mention or we may not mention for the decimal numbers. So in this, we are just for making this MSB and LHB, for the hexadecimal, it is taking up to A to F along with 0 to 9 values, that one. So here I have to mention H means what? This is a hexadecimal. You understand that this is hexadecimal. So D, so here I have to use it for the binary. Two base we have to use it. It is a binary. Either it may be a 10112 or it may be a 1011B. B in the sense binary, 2 in the sense also binary. Any one of the fashions you have to use, both the fashion is right. And in the decimal, either with the base we have to use it 10 or it may be a D, the symbol D. That is a decimal, or as I said now, it may be a only the number. If there is no any suffix is there, it means that you understood it is a decimal number, because always the decimal number is having a uh, by default it is a decimal number. Either you have to mention D or you may not mention D. And in the next number, that is B to 5A, this is a one of the hexadecimal. Either you have to use the suffix with 16 hexadecimal or you have to use the suffix with H value. You have to use the suffix with H value. So in this way you have to uh, specify the numbering systems. So because these concepts are very important while writing a programs, so this is not a syllabus, then also I have to made added here. So in this you have to use. And one more thing, for the string constant, see in C programming, please am I audible, right?
Yes, audible.
ओके थैंक यू सी समटाइम्स बार बार मैं चेक करता हूँ फिर भी मे बी नेटवर्क के प्रॉब्लम्स ऑडियो मे बी ऑफ दैट्स व्हाट बार बार आई एम चेकिंग विथ यू पीपल okay thank you so here in the string constant we have to use it arithmetic operators we have to use it logical operations we use it sub expressions we use it that is name of the instructions like identifier we use it. So as you studied in the C programming, almost there is a two kind of alphabets. One is character and one is string. Character constant and string constant. So how you specify in C programming character and string? The character you specify is by single quotes. That is inverted comma, single quotes, right? If it is a single quote, then you say it is a character. And if it is double quote, you say it is a string in a C programming, C++ programming. So that is single quote comes means that is a character, double quotes comes means that is a string. But it is not like that in the microprocessor. Wherever you have to declare string constant, that time you have to use single quote. There is no double quote for the string constant. Double quotes you have to use it for some other concept, that is for arithmetic operators. So for the using arithmetic operator, you have to use double quotes like this. Arithmetic operators may be a addition, maybe a subtraction, maybe a multiplication, and maybe a division. You have to use double quotes. Wherever the arithmetic operations comes, that time you compulsory use double quotes. Otherwise, your program becomes an error. It will use the error. And wherever you have to use the string constants, that time you have to use single quotes. String time you have to use single quotes in the microprocessor. Please don't confusion these 2 points with your C or C++ program. These two are different from C and C++ program because you don't compare this microprocessor with C and C programming. So in the microprocessor, single quote means all the string constant declaration, and double quotes means all the arithmetic operations, addition, subtraction, multiplication, and divisions. And as per in the logical operations also, you have to use double quotes only. Arithmetic and logical operations, both you have to use double quotes. And or, not, XOR, XNOR, NAND, like that, you have to use all operations of logical, you have to use the double quotes. So next, for the sub expressions in a microprocessor, you have to use it for the part of another expressions is delimited from its parent expressions by the parenthesis. So for the sub expressions, always you have to use parenthesis. That you say no, that is a flower bracket. You have to use a flower bracket. Here you have to mention flower bracket. Please note down this, okay? That one you have to use flower brackets for the sub expressions. And for the identifiers, there is the name. So user can the programmer, we like we or you, the programmer, the user can give the any name for the instructions for the identifier, that expressions constant and string constant. This is the expression constants and string constant, or for only the expressions we have to give the name as per our convenient. It is a possible and it is supports a microprocessor. Okay, so this is, and for this identifier, even C languages also you have to study some keywords and identifiers, right? Some keywords and identifiers you studied in C programming and in C++ programming. Here also some identifiers are there, the keywords are there. So for the rules for the identifiers and keywords, so in the first point what I mentioned here, the order of precedence to operations is the same as it is for the C language, because our microprocessor, we say it is a machine level languages or assembly languages. The assembly languages in the sense it is a high level languages for that microprocessor. So in that we have to use an identifier. What is the identifier? It may be a label, it may be a variable. Label now only have to start that branch kind of things. It may be a label, you say it is an identifier, and it may be a variable, whatever the variable you are using in the microprocessor, or it may be a name consists of starting up to 31 characters. So the maximum storage capacity is 31 because it is a 16-bit. 16 into each time 2, that is multiplied by 2. 16 into 2 is 32. So for 0 to 1 characters, that is exact last storage capacity is 31 characters in that identifier. And the characters must be, it may be a letters. Characters is a letters, or it is a digits, or it is a question mark, or it is a underscore. So the characters of the identifier, it may be a letter, digits, question marks, underscores, or you use ampersand. But the question marks and that ampersand is not allowed in C programming. I think you remember while you studying C programming. But these two special cases, at the rate and the question marks, is allowed in C, that microprocessor. Remember that in the identifier, that is the characters must letters, digits, question marks, underscores, and at the rate symbol and sign, except that first character cannot be digits. So the only one condition is restrictions, that is the first character cannot be a digits. After consequent of first letter, you may use the digits, but not first digit as a first place character as a digit. Okay, this only the one instructions. Remaining more benefit, at the rate we have to use, and the question mark also we have to use in the microprocessor. And the last point, which is the identifier, that cannot be a keywords. Identifier cannot be a keywords like you are in C programming. So whatever keywords you have to use it in the assembler language, such as that keywords in the sense what instructions. So for the example, add is the one instruction. So that add is nothing but it is a keyword. What is a keyword? Keyword is, it is a particular value, particular name or fixed name. We can't change it. The implementer or the inventor, they have to specify a particular name, and they have to built in use it in the awesome software. Those we say it is a uh, keywords, so that keywords are not going to be changed. But identifiers are user defined. Identifiers are user defined. Keywords are built in, already present in the tool. So the identifiers cannot be a keywords used by the assembler, such as the instruction mnemonics, and the register names and the special operations. These are the keywords. We don't use this one as a identifier. We cannot be used keyword used by the assembler, such as that instruction mnemonics, the register names, and special operators. So this concept, just you remember, you go through it. So whatever I explain now for the rules. So once you come to know this theory part, next I will move to instructions. So as per our slides, so these things I have to explain. And these are the addressing modes. Just I have to recall whatever we used in the second unit. All immediate, direct, register indirect. In again they used three, that is relative, indexed, and relative based index, and branch. In that branch we have to use it four. So this is things. So and next one, these we have to use it variables, constant, string, constants, arithmetic operators, logical operators, sub expressions, names, and rule. All these rules, and I have to explain it. Okay. So next, we will move to actual instructions. So from this topic onwards, we have to start particular or actual instructions part from the unit number 3. So dear students, one example I'll so in that also different types of instructions are there. At the first point, we'll take data transfer intake instructions. So just for come to the point, uh, that is, yes, see here, these are the data transfer instructions. There are totally 10 in number. 10 data transfer instructions are there. So today, just we have to study these 10 instructions. After that, we will move one by one. Just today, we will study these 10 instructions, and in detail, we have to study because these instructions, whatever comes, move instruction, push instruction, pop instruction, push with the flag, F in the sense flag, pop with the flag. This is the exchange, and this is the exchange with the BX register, and load effective address register, and loads with the string, loads with the destinations. Okay, these kind of 10 different instructions we will study now. So now I will go for actual instruction sets. So as per your syllabus, I will show you. So this is the part of assembly instructions format, what I explained to you now. So now I will move to the second topic, instruction set. Actually, the entire this third unit is nothing but an instruction set of 8086. Main 8086 is instruction set is nothing but your entire third unit. So now I will move on instruction sets. So in that first one, I will take data transfer instructions. What are data transfer instructions? The first one is move instruction, uh, push instruction, pop instruction, and push with flag, pop with flag, exchange with the BX register, and load effective address register, and loads with the destination and source we have to use. Okay, so this is the list. Now, one by one, we will look into that. Dear all students, move instructions many times I have to use it. Still, some students are having doubts because I didn't explain it in depth. Why means from this chapter onwards, you have to study in depth of each and every instruction. In depth of each and every instructions we are going to study from this lecture onwards. Please remember. Okay, for that, from these lectures onwards, all the lectures of third unit is very, very, very important. So this 8086 instruction set, I have to take minimum three lectures. So it means minimum 6 to 7 hours it needs. Okay. So dear students, in the data transfer instructions, as I made you a list, one by one we will go through it. So the first one is move instructions. So the format of move instructions is nothing but this one, that is move destination comma source. So move in the sense what you are going to be move one, there is a one thing from one place to the another place, or you maybe a transfer one place to the another place for a particular thing. That one we have to give a definition of move, right? Same way in the microprocessor, the move instruction will work on that. What it will do, it will move the values or the data or the information, whatever that containing source. This is the source. Always it is move source to the destination. So if we have to move a particular things means source is a one point, destination is a one point. Source means from where, and destination means to where. So from to, you say from in the sense source, to in the sense destination. From the source to destination you have to transfer. Always this is the format of the instruction. So here I have to miss the label. Label I have to miss it because we don't go to do the any branching with a single instruction. And after that there is a mnemonics. What is a mnemonic? Here the mnemonic is nothing but a instruction, which is a move. And here these two are the operands. Operand number one, destination. Operand number two, source. Always you have to use in a format in such a way that move right to left. This is the right portion of ours. Source is the right portion and destination is the left portion in the operand. So right to left you have to move, that is source to destination. You have to transfer the data. So it means that the move instruction, whatever the source register, these two are nothing but a register, source register or destination register. Whatever the source register is containing a value, containing a data, or containing any kind of information that is going to be transferred it into destination. That's the meaning. So here in the sentence clearly I have to mention moves a byte or a word. Means byte or a word in the sense of what? It is a data or information from the source to the destination and specified in the instruction. So whatever that instruction is specifying, it is a move. Move in the sense transfer. So that is the content of value of source is transferred into the destination. I request you please, all my dear student, more concentrate. Actual the programming concept, microprocessor you have to learn from this point onwards. Okay. So in this, so the second point, yeah, please, any doubt? Hello. I think I heard some voice.
Repeat, sir.
Okay, okay, okay. Can I repeat it right? See, this is the format of uh, that instructions, assembly languages instructions. So what is the format? As I explained in the previous class, this previous time. So this is the format, right? So this is the branch label. This is the mnemonics instruction. This is the operand one, and this is the operand two, and this is the comment lines. So as per our example, I'm using only one instruction means no need of branch, right? No need of branch. Whenever we have to use the branch means call by and value and call by represent like a C programming. So we have to call from some other positions. We have to use it, right? So in the single instructions, there is no need of branch. That's what I didn't use as my now example. So in that example, okay, in that example, directly I have to use the mnemonics. Mnemonics is here. I have to use a move, and operand one I have to use it as a destination. Operand two I have to use it as a source. So move destination comma source, the meaning is whatever the data or the information containing a source, that is going to be transferred it into destination register and stored it in the destination register. That is the meaning. So here in the expressions clearly I have to given a text moves a byte or a word in the sense of what? It is a data or information moved from source to destination. So source is the right side as you are visible, and destination is the left side. Move from right side to the left side, that is source to destination, with a particular instruction or specified instruction. What is specified instruction? It is a move, it is a transfer. Okay. So here in this, the source and destination. Source is the register memory location. This is the storage area, register memory location, and we call it as immediate number. It may be any kind of value is stored. And destination is what? It is also a register memory locations, but wherever that data is comes from the store, it is comes into the destination and stored in it. That is the meaning of move destination comma source. Like this, it is a move ax comma bx. What is ax and bx? These are nothing but a memory locations, a register and b register. So move ax comma bx in the sense what? The bx containing a value is transported into ax register and stored in the ax register. That is the meaning move instruction. So here in the source and destination, both source and destination cannot be a memory locations. So one is the data containing the location, and one more is the place where you are going to be store the data. But here in this your example, the source is nothing but it is a data content location, and that data is transported into a memory location of destination of the point. So here, for example, here this is the general format for the move instruction. So with the examples I given here, so for example, move cx comma 0037h, same value I have to given in a register addressing modes. You may remember. So this meaning is the value of 003h hexadecimal value containing present at the location of source, present at the location of source. So that location of uh, 0037 value is going to be transferred it into C register. The C register may be a vacant, they may be empty at the beginning. So move CX comma 0037H means the 0037 hexadecimal value transferred it into CX register and stored in the C register and to stored in the C register. That is nothing but the 37 hexadecimal value is comes into CX register. It is a comment. It is a comment I have to give. In the second example, same move BL, which is a 4000. See, these values this rectangle bracket, you know that is register, related to register, related to index register, like that. So here in the second example, that BL comma 4000H. What is this 4000? The 4000 is nothing but it is a memory address. It is a memory address in the hexadecimal. So this memory address, whatever containing the value, so that's what I have to use DS. What is DS? Data segment, right? Data segment is nothing but a memory. That memory location, the name of that memory location is 4000H. Started from 4000H of data segment register value, that is transferred it into BL. Either it may be used L or H, not a problem, because in general you have to use BX. L is for lower nibble, H is for higher nibble. Generally you have to use BX. If you have used particular to the lower nibble, that is used the BL register. Same way in the third example, AX comma BX. Whatever the value is containing BX, data is containing BX, that is transferred it into AX register, because move in the sense that is a transfer. And in the fourth one, DL comma BX, again it's a relative index. It is just a index. It is a relative index as you studied in the adhesive modes, that is transported into DL register. Same way BX to the data segment. So the move instruction, this is the main explanation of move instruction. What purpose we have to use move instructions. So very important. Today you have to learn only one instruction, but you have to learn perfect. Then only you have to understand the concept of microprocessor programming. So am I clear about move instruction?
Hello, sir.
Yeah.
Sir, please explain the second instruction. Move BL in bracket 4000 hexadecimal.
Okay. See, there is here move in the sense that is a mnemonic. BL in the sense B is the register. Either you may use it L or H. And this 4000 is what? The 4000 is particular memory location. So what is the memory? The main memory we have to say data segment. The main memory we have to say data segment. So in that data segment, the different kind of data memory locations are there, right? So for example, if our memory is started with 4000, later on the data is stored in 4001, 4002, 4003. 4000, what is it? Is not a value. 4000 is a memory location. Value is different. In the first example, you say this is the value, that is 37 is the value. Direct value you have to transfer, that time memory is no need. But here the 4000H in the sense it is a location of the memory, where that memory location is present, that is the data segment register. Data segment is nothing but what? That is the main memory, your hard disk memory. In that hard disk memory, this is the value, this is the address of a particular memory. This is the address of a particular memory. It address may containing any value. We are not looking into that. Just whatever the 4000 address is containing a value of the data segment register, we have to transfer that value to the BL register. Which value we don't know. We have to specify maybe any number of values, any kind of values. That values we are going to be transferred it into B register with a lower number. Am I clear?
Yes, sir.
Okay. So please, I want more. I want more notes from this instructions. Like this only, if you have to perfect one instruction, later instructions easily you have to understand. That's what. First instructions, if you be perfect all of you, then only I move to the next instruction. As per the list, I'll show you again. So first instructions I have to cover. First instructions in the out of 10 instructions, data transfer instructions. First instructions I have to cover. Please, any doubts again? Who are asking the question now? I'm very thankful to you. Okay, like that. If any questions, any doubts?
No, sir.
Okay. Yeah. Yeah, fine. Okay. Then I'll move to second instruction. What is second instruction? Push. Push instructions I have to use. So one thing I'll clarify you here only. So in the move instructions, I have to use two operands. Why means move means what? We have to transfer. For transfer करने के लिए, for transfer करने के लिए, source point is need and destination point is need. It means that from where to where, from to, we have to transfer it. Any one of the things. For from to means compulsorily we have to need 2 points, source and destination. That's what in the first instruction I have to use destination and source. But here in the second instruction, push source. Here just I have to use only a one operand and one mnemonics. Why one operand means, see, whatever data and wherever data are there, we are not bothered. Just we have to push into the stack. We have to push into the stack. So the stack may be a full or maybe a empty or maybe a some values in the stack. But what is our aim? Just we have to entered some value into the stack. From entered some, because stack is we know particular, that location stack is we know. For that, source is we must and should need. From where? From where we have to transfer the data into the stack. Stack is a fix. That's what we have to use in along with the push, only source operand. Remember that. Only source operand. And same way for the pop instruction, we have to use only a destination. Because pop means what? We are going to be remove, right? We are going to be remove a particular point, that is destination point. Whatever you have to done with the push, push become a source and pop become a destination. So now you will explain here, that is, now I will move to the instruction. Second instruction, push instruction. So this push instruction, push is a mnemonics. So because of one instruction, we no need to do the label or any branch. And here only one operand is more than enough to enter the data into the stack. Stack is a fix, right? So we need from the where we have to take the data and add it into the push. For that, where we have to take from where, in the sense, from in the sense what? We have to use the source. Only source is need. So here no need of destination or any other kind of operations. So in this explanation, for the push instruction, push the source into the stack. Push the source into the stack, because stack is a fix. Stack is a fix. We don't call it as a destination. It is a fix value. Memory is knows, oh, this is a stack. Once you have to declare the stack, that stack memory is created. So, but our aim is from where we have to transfer the value, we have to take the value. That taking point we call it as source. For that, we have to use only a source operand with the push instruction. So the push the source into the stack and decrement the stack. So in the stack, always you are going to be decremented, right? Top minus one, top minus two. So because of it is 16-bit, every time we have to decrement by two value. That is, decrement the stack pointer by two, by number two. Because of 16-bit, you have to stack each time by two, top minus one and top minus two. So for that, the source must be a 16-bit word. That is a must be 16-bit word. So and source, that is a source is the offerand, which is a register to memory locations. The stack is fixed memory location, that is going to be enters the value into the memory location registers. For example, here push CX, only one operand is more than enough. CX. push the data into the CX register. Just we need where we have to push it. So here SS in the sense what? It's a stack pointer like your DS. DS is the main memory and it is only a stack segment. Because of push and pop compulsory we have to use stack. It's a stack segment, but previous for the move instructions we have to use data memory, that is for DS we have to use it here DS, that is data segment for the move register. But for the push we have to use stack, so that's what we have to use stack segment. So in that first operation stack pointer -1, how you have to use it in data structure and C programming, top -1. So like that you have to use stack pointer -1 for the first value CH value, and stack pointer -2 for the CL value. L is for lower and H is for higher. For the lower, 1 SP -1. For the higher, lower, again SP -1. So here SP -2. So that meaning is totally stack pointer -2 to the segment point. That's a stack pointer. So final the stack pointer storage value is SP -2. So like this instruction is works. What is that? SP -1, SP -2. The total stack pointer is going to be used here. Push CX. That is the meaning of push CX. Same way, one more register, push DS with the data segment register. Same way you have to do SP -1, SP -2, that DS value to the stack segment. SS. Whenever push and pop comes, that is a stack pointer. You are going to be use it here. Okay. So this is about push source, push instructions. So just remember that push instruction is means we have to use it for to do the stack operations, push operations. So for that only one operand we need, that is the source index. So that is a source operand we have to use. So this is the meaning of push instructions. So for the 16-bit we have to use two times. One is for H and one is for L. One is for H and one is for L. That's what the stack pointer is the thing, but SP -2, and finally that is go and store it into stack segment. Same way in the second answer. Am I cleared? Second instruction, very easy instructions. By name itself only it indicates we have to use it for what purpose. So just you have to remember that format. Either we have to use source or we have to use destinations or we have to use both, like that. Based upon the name, you have to make segregate these instructions. So am I clear? Second instruction.
Yes, sir.
Okay. Now I'll move to third instruction. Same as second instruction. Push, that opposite is pop. Same as second instruction. Here you are going to be decrease. Your stack is going to be decreased minus. But in the pop, what you will do? You have to make addition plus. You have to make addition. So here in the pop word from the stack into this given destination. And in one more thing, the pop is opposite of push, means here in the push you have to use source, but here in the pop you have to use destination. Opposite destination. And in the push you have to use SP -1 and SP -2, but here you have to use SP +1 and SP stack pointer +2 in the pop destination. So here this is also a 16 bits. That's what two you have to make increment, that is destination register, that is except code segment with the memory location. For the example, pop CX. So how you have to use the push CX in the push source? Same way you have to use it pop CX. The pop CX means, which is the thing, but C is in the sense what? Either you have to use L or H. For the H, one stack pointer, and the for the L, low nibble stack +1, stack pointer +1. Same way how you use the data structure for the pop operations, stack pointer +1. So for the higher nibble, you have to use a stack pointer and store it into stack segment. Same way For the lower nibble CL, you have to use it stack pointer plus 1 with stack pointer and store it into CL register. Finally, the stack pointer is containing the value of stack pointer plus 2 and stored it into CX register. Same way in the POP DS, that is stack plus 1, that is stored into SP, and that finally stored it into stack segment, which is of the register is DS. So stack pointer plus 2 with stack pointer. So this is the exact opposite of your push operations. So push means you have to enter the value, pop means you have to remove the values from a stack. Okay, so for that we have to
Sir,
use.
what is mean by stack?
Okay. Yes, fine, very good. Very nice question. So stack is what? See, for example, there is a bucket. In outward example, there is a one bucket. So in the bucket, bucket is used for what? Water, right? So that bucket is nothing but a stack. Bucket is nothing but a stack, and water is nothing but a value or a data. If we have to enter a water into a bucket, that is a push operations. If we have to remove the water from the bucket, that is a pop operations. So particularly we say that the stack, the meaning of stack is nothing but it is a memory location. It is nothing but a memory one. Am I right?
Okay, sir.
Okay. So stack is nothing but a memory. That memory, what purpose we have to use it? We have to use to store the data, more data, or we have to use it to make free to the data. We have to store the data means that is a push operations. Whatever our data is there, we have to load it. We have to store it in the memory. That is a push operations. And whatever we have to make free to that memory, it means that we have to pop it. Whatever the value, we have to remove the data or the value from the memory. That is pop operations. So just for your understanding purpose, bucket is nothing but a memory. It is a memory. Look, it's a size of it's not size of memory, it is just a memory. How much we have to enter the data and how much we have to make free to that. For example, one bucket, it may be a 10 liter of capacity. So the bucket is having a only 2 liter. Again, 8 liter water we have to enter into that bucket. So it means that the stack is the total capacity is 10 liter. 10 liter of data it is having a capacity. Otherwise, if we have to make free to that bucket, some more space want to make free, that time we have to remove some liter of water from the bucket, so that some vacant place is vacant. That time we have to say that is a pop operations. I think I cleared you. So is there any more questions from these three instructions? So these three instructions, one instructions I have to explain it, move destination comma source. Second instructions I explained push source. Third instructions I explained pop destination. So in these three instructions, any doubts, please? Otherwise, I will move to fourth instruction.
Sir, pop destination, please repeat.
Pop destination. So yeah, see here, pop means what? That you have to going to delete the value from the stack.
Hello, sir.
Yeah.
To understand pop register, we will know to the second register. So please explain second register side by side.
This one push source.
Yes, sir. Yes, sir.
Okay. See,
When push source we understand, then automatically pop source we understand.
okay. Once you understand push, automatically you're going to understand pop, because
Yes,
both
sir.
are same with reverse or with opposite. So here, all of you studied data structures, push and pop. Is it covered that syllabus or not still as your syllabus? Hello, please. Are you audible to me, right?
Yes, sir.
Yes, sir.
Yes, sir.
So that pop operations, push operations is not studied still in data structure. Please answer.
Yes, sir.
Yes, not yet.
Oh, not covered still. I think you didn't reach to that topic till now. Okay, in the data structure, it is there in detail. So, see, first, in general, you have to understand push in the sense what? There is a some memory, there is a some memory space. That memory is maybe a vacant, not a full size. So some extra data, extra information or extra value you are going to add to a particular memory, that is nothing but push operations. So push operations and pop operations, sometimes we have to say overflow and underflow. Overflow means what? If the stack is full, the memory is full, again you have to enter some value into that memory, means there is no capacity to again store that value, right? Because once the memory is full, after that you have to enter some more value to the memory, means it is not taking again some more value. It means that we have to say that condition is stack overflow. ओवरफ्लो फॉर एग्जाम्पल सब हम सब लोग खाना खाता है, खाने करते हैं तो हमारी कैपेसिटी क्या है? और मेरा कैपेसिटी है 2 चपाती खाने का. So my capacity is 2 chapati. So I have to eat two chapati. After that 2 chapati, again you have to force me to eat. What it will do? It will start to omitting, because it is not accepting, means that we have to say overflow. So in the same way, that memory, if you have to, by using instructions in the microprocessor, if you transfer the data or if you move data to a particular memory locations, in that the particular memory is already full, particular memory is already full. For example, the one memory is having a 2 bytes of 1 MB capacity. Again, you have to add 2 MB, means it will not it will not store, right? That time overflow is occurred. That time exceeds. The flow is exceeds. So here in the microprocessor, one memory location, whatever the value you are going to enter into some memory of the computer. Some memory means what? That is the source of a computer. So that one you are going to be do the manipulation in the memory. So that is nothing but we have to use the push instruction. First of all, you understand, for that purpose we have to use push instructions. So push instruction is only related to the source, because the memory location is already available, the source point is already available. That's what we are going to play with, the only source point. So in that source point, the push source, for example, push cx. What is a push? It's a mnemonic, it's an instruction. What is a c? C is a register, what we studied in architecture of 8086. X in the sense, either it may be general, it may be lower nibble or higher nibble, h or l. X means, so this is the one register, that is name is C register. If we want to add some values to C again, if we want to some value to C, what we will do? For example, there is a one bucket. The bucket is having a full of water. If we want to enter again some more water to the bucket, that bucket will not accept the remaining water. Okay. So for that, we have to check the CX condition. We have to check the bucket size condition, what is capable to store. For that, we have to use just a second. Okay. So
to check the condition wherever we have to enter the data to a particular memory location. C is the particular memory locations. We have to check it first. We have to check it first means that top minus one is possible or not. Top minus one means is there any place is vacant in that particular location. So for that we have to check. That one is nothing but stack pointer minus one. If stack pointer minus one is 0, it means that there is no addition of values into the stack C register. So that purpose this one we have to use it. So the particular meaning is what, whatever we have to data is there, that one we moved it, we placed the location of C register. That is the main meaning. So for the 8-bit and for the 16-bit we have to use it. 8-bit is the 8085 and that 16-bit is the 8086. As we already studied, 8086 16-bit. So for that, one is 16-bit means H and L, 2 points are comes in the place of X. For the H purpose, high nibble purpose, we have to check one condition, and for the low nibble purpose, we have to check one more condition. So totally 1 plus 1, that is the, this is the 1, and plus this is the 1, and totally it becomes a stack pointer minus 2 condition we have to check in the push operation. So that push operation is stack minus 2, we have to use it. If it is a vacant, then only we have to transfer the value into this. If it is not vacant, again we have to use some other register. That is the main concept of push instruction. Got it now? Are still confused?
Clear, sir.
Okay. So same way, how you are going to enter the data into a particular memory, particular register like a C, same way you have to remove the data from the C register. How? See here in this example, pop CX. If you have to remove a data from a particular register, that data should be present, right? If for example there is a one bucket, the bucket is having a 0 water. The bucket is having a 0 liter of water. Again, can you remove the water from the bucket? Because no water only there in the bucket, there is no possible to remove the water from the bucket. Am I right? It means that we have to say it is an underflow. Underflow means what? There is no data is available. Still, we have to remove the data from that memory location. That time the error is used. That one we have to say underflow. In the push, that is overflow. Whenever the data memory is full, again you have to enter the data into the memory. That is overflow in the push. But here it's a underflow is occur. That is with the same way in the push there is a H. For the high nibble you have to make it as a 1 plus, and for the stack pointer, main top stack pointer, and the low nibble you have to use it for one more stack pointer. Either the value is there or not in the data. For these two conditions you have to use the pop operation, that is a pop CX. So CX is a register or a memory locations. If the data is there or not, you have to check. If data is there, then only you have to remove the data from the C register stack point. If there is no data, then there is no need of remove the data. Otherwise, you have to getting the errors in that. So for that pop CX register, it means that in a single sentence we have to say, as our requirement of the C register, we have to remove the data from the C register by using a instruction of pop. By using instruction of pop, we have to remove the data from the C register. It may be C register, B, D, whatever register. Just one example, I have to give you CX register. So these things, once we will start practical session, you will more clear in that time. Just this is theoretical part. That's what. Still now I didn't started practical sessions. Okay. So once we start practical sessions, you will more understand into that. So I think, am I clear this push and pop, right? So Is it enough or can I again continue some more instructions? Dear students, am I audible, right?
Yes, sir.
Hello.
Yes, sir.
Okay. So next, same way, push F as per our list. That is move instruction. See, after this class, I will share these notes with you. Please, you have to go through these notes again. You have to more clear. And also, we will start actual practical. That time you will clear 100%. Okay. So here next, again I will go to. Now I have to start move first and second push. Third one is pop. Next, fourth and fifth instructions are again push with the flag and pop with the flag. Flag registers already you saw, either it may be 0 or 1. 0 means it operates, 1 means it is not operates as our general instructions. Okay, so now I will move to the instruction fourth one, that is push F. Push the value with the flag register. Here, without flag register, you have to push the value into the CX register without flags. But here in the push F, F indicates it is a flag. You have to push the value with the flag register into the stack. Flag is what is the flag register value? Either it may be 0 or 1. 0 in the sense working, 1 in sense not working, or it may be a full. So here push up in the sense that is a push with the flags, that flag register into the stack, and decrement the stack pointer if the data is available. If the data is available, you have to decrement the data by 2. For 8-bit it is 1 by 1, and for 16-bit it is by 2. So 8086 is 16-bit. For each time by 2, it is going to be decremented. So push F, that is again a stack segment with a stack pointer 1, stack pointer 2. We have to use here flags instead of the values. We have to use flags. So what is different between flags and the values? Values may be any kind of number you have to use, for example 10, 20, 30, any kind of number you have to use. But flag in the sense what, either only 0 or 1 you have to use for the condition. For the condition purpose, either 0 or 1 you have to use. So for the higher nibble and lower nibble, these are the 0 and 1 condition. But only the normal push, there you have to use the push, that is the value in the normal push. But here in the push flag, for the flag purpose, you have to use either 0 or 1 with the stack pointer. Again, same, everything is same with the stack segment only. Again, same with the pop F, that is the pop with the data or a word from the stack into the flag register by 2. Again, by 2 in the sense what? In the pop, always you have to do the addition plus, and in the pop, you have to do the minus. It is decrement and it is increment. Pop is increment and that push is decrement. So here in that pop, again flag L, that is stack pointer with the SP and SP plus 1. So totally 1 and 1, that becomes a SP plus stack pointer plus 2 into the stack pointer, that is stored it into a particular value. So here in the pop and the push, you have to use one operand, that is source with the push and pop with the destination. But here with the flag, you don't use any operand. Please remember, why you don't use any operand means that is also a fixed value, either 0 or 1 in the flags. That's what we don't use any operands, because by default either 0 or 1, either working condition or not working condition, it is going to be decided. That's what we don't use any operand with the push flags and pop flags. Okay, so these two you have to just remember, just you go through it. So next one, I'll take the sixth instruction as per your list, that is exchange source, destination and source. So here, dear students, XCHG is nothing but exchange, or we have to say swap. What is swap? Swap means exchange the value from one to another. For example, if A is containing a value of 5, B is containing a value of 10, then we have to exchange A and B. It means that A becomes 10, B becomes 5 value. Like that, in the microprocessor also you have to exchange the value of one register to the another register. Source is a one register, destination is a one register, that is going to be exchanged. That is the sixth instruction that is going to be exchanged. So here in this exchange a byte or a word or any kind of data between the source and the destinations. Whatever source is containing the value, it transport it into a destination, and whatever the destination is containing the value, it transport it into a source. That is exchanging. So here in the example you have to see exchange cx comma bx. It means that the bx transferred it into cx register, and the cx register is continuing transport it into bx register. Okay, so here both cx and bx both are in memory location here. That's what the source is a memory location and the destination is also a memory location. So both are memory locations, both are containing the values, just the values are transferred each other. bx का वो कितना वैल्यू थे वो cs को ट्रांसफर करते हैं, और वो cs में कितना वैल्यू थे वो bx को ट्रांसफर करते हैं. So that is done by the instruction xchg, that is exchange instructions. Okay, so it exchange that xchg cx comma bx, in the sense that bx containing the value is transported into cx and cx containing value is transported into bx. That's what I have to show both direction arrow. That's what I have to show both directions arrow. Same way in the second examples also, bl with ch, that is transport the value with each other. That is a exchange destination, sixth instruction. So next, the seventh instruction, that we say it is a memory location exchanging. So here in we have to move the AL. AL means what? It is an accumulator. By default, it is there. Accumulator that contains of the memory location in the data segment whose effective address is formed by the sum of BX and AL. So here that XLAT, for example, the XLAT, in the sense here again we don't use any operands. Exchange we have to use operand, means for the exchanging destinations also we need, source also we need. That's what we have to specify. But in the memory locations, by default it is happened in the memory, and very rare we have to use this instruction. Majority only one or two cases we have to use, but anyhow it's there for our syllabus, so we have to study. So this XLATB are sometimes XLAT, that is nothing but the accumulator register memory location. The contents of the memory locations, that accumulator with the memory locations data segment, that is effective address is formed. So for that the sum of bx and al register, bx in the sense that is the base register with the al register, so that xlat in the sense what, so bx plus al, addition of these two values stores it into a data segment, and that data segment memory location 2 stored in the accumulator al register. That is the a register. A register we called normally it as a accumulator. So this way we have to use the XLAT or XLATB. So it means that, so for example, if DS equal to 1000H, that memory location is started with the 1000H, and that BX value is at the some more place with the 200H, with the 200H, and AL is with the 03. How it is going to be adds? It is going to be adds. It means that sum of AX and BX and AL, it is going to be add. How it is going to be add? That 1000 memory locations in the 16 number system, which the bx is 200 0 2 0 2 and that accumulator is going to be 03. So finally we have to add, that becomes a xlat value. Exactly, xlat value, what it will do, it will add the bx and al register containing the address, that is finally 1200 03 10203, that al is containing the value. This is the XLAT. It is very rare we have to use, but we have to study anyhow. So next, the instruction is eighth instruction, that is LEA So again, it is a register comma source, because LEA in the sense what? That is a loads effective address. So effective address, we are going to be loaded from the one place to the another place. So one place is nothing but a source, and another place is nothing but a register or a memory. Register or a memory we have to load. So what is that meaning? The source containing the value, we have loads onto the register. Source containing the value, we have loads on the register. That's what the load effective address or offset address of the source into the given register. Whatever given register, we are going to be load it. We are going to be dump it. For example, LEA BX comma total. So total in the sense what? It is a user defined. So that total is going to be stored into the BX register. The B is a register. So this is the total is nothing but what? It is a effective address. So the effective data, that effective data is going to be load it into the B register. That is BX offset address of total in the data segment. So next one, ninth instruction, that is LDS, that is destination, register and the source. So LEA in the sense what? It is only the register and the source. With the source, any kind of register you have to use. But LDS means particularly you have to use a particular destination register. For the source, you have to transfer the total value to the particular register, that is same as LDS BX comma total. Same as your this one, but this BX register in the LEA, whatever location we have to use, but in the LDS, particular location of the destination we have to use. That is total value to the BX register stored. Okay, so this is the ninth instruction, and the last instructions for the data transferred into the instruction, that is LES. The LES in the sense what? It is a to loads the destination register into the ES register. What is ES? That is extra segment. There is some extra segment part is also there in the memory, as you saw in the architecture. So the LES destination register comma source, the source is going to be transferred it into a destination with a extra segment register. That's what E is comes instead of D. E is comes instead of D. So loads the destination register and ES register with the offset address and the segment address indirectly with a specified by the source. So that's what source and destination register with the extra segment we have to use. For example, LES BX comma total. So here in the 10th also same example, BX comma total, BX comma total, BX comma total, but only change is it is a extra segment, it's a destination, and previously is the normal, any register we have to use. So in the 10th one, that is loads the destination register and ES register with the offset address and the segment address indirectly. So for example, that is LES BX comma total in the sense what? All the total which is containing the values of address in the data segment memory, that is going to be transported into BX register. This is the BX register. So dear all students, today I have to cover. So am I audible, right, all of you?
Yes, sir.
Okay. So by today's lecture, just I have to cover 10 instructions. Just I have to cover 10 instructions. These are the 10 instructions. This is LES, not LES. Okay. So these 10 instructions, just you have to go through it. Only these instructions make you perfect. I will send you my notes today only. I will send you my notes immediately after this lecture. So all of you please go through this and make a points wherever the points you are not cleared or you have getting any doubts. Again, we have to discuss on these 10 instructions in the next lecture, and we will move to further instructions. So first, today's our aim is to perfect all these 10 instructions. So whatever the doubts, whatever the understanding point of view, just you go through it. I'll send you these notes and be perfect. So just a minute, I'll take attendance, all of you. Just a minute, all of you down to go for logout. Just where is, okay, 105 students are there. So just all of you just wait. See, A24, Pradnya and Diksha, you both are mentioning. Okay, A24. Yes, yes, okay. It's okay, fine. 27, 28, 29, 30, 31, 32, 33, 34. 38, 41, 42, 43, 44, 45, 50, 52. See, Aradhya Gokde, what is your rule number? Aradhya Gokde, what is your rule number? Otherwise, I have to make you absent. Just you have to mention the name. Aradhya Gokde, please tell me your rule number.
Sir, Aditya Godke it is. 39 roll number.
Aradhya Gokde 39, na?
Sir, Aditya Godke.
Your number is 39, right?
Yes, sir.
Okay, okay, fine. So you have to mention your rule number, no? Then only we have to easily recognize to you. Anyhow, fine, you have to change it. So 05. 0708. Okay, fine. Dear all students. So here, these notes I will transfer to you through the WhatsApp. So just have a second. I'll transfer to you only now. So in the microprocessor, that microprocessor group, all of you there in the microprocessor group, right? So is it necessary to write all syntax of instructions in uppercase? Dear students, okay, one question I got from Praveen Avalkar. Okay, so here in the instruction set of microprocessor, there is no case sensitive. So please, am I audible, right? Hello.
Yes,
Yes,
sir.
sir.
Okay, so one question I got this one, that is it necessary to write a all syntax of instructions in the uppercase? So please don't say syntax word, you say just instruction. It is not a syntax. Okay, anyhow, so uppercase and lowercase not a matter in the microprocessor instruction. You may use uppercase, you may use lowercase, not a matter. In your TOSM installation time also, I will say you whatever you have to use the command. Either lower case also you have to use, either upper case also you have to use, not a matter. Okay, so any case you have to use, any case you have to use. It is case insensitive because okay, because microprocessor is case insensitive. Okay, so this is the answer, please you check it. So okay, fine. So here I will send you, attach this third unit notes, that is in the, okay, so here it's very, so in that very we have to use microprocessor. So 1 second, here the unit number, yes. So these notes I attached and I transfer to you. Okay, get all of you get it. Any case you have to use. Okay, dear all students, I attached my notes, third unit notes. Please, all of you go through it. So only today, very small topics I have to explain it to you. Only 10 instructions at the basic data transfer. 10 instructions I have to explain. So every lecture I have to explain 10 to 12 instructions, and like that we have to cover. So all of you please go through all these instructions, and whatever the doubts arises, please you make a list and we will discuss in the next lecture. Thank you one and all today who are attending the lecture and patients listening. Please try to do more study. Okay, thank you. All of you give attendance and you have to make log out. Thank you one and all.